Hello, today we're going to talk about multiplying radicals. And radicals are really things that have stuff underneath a root. So it could be a square root, cubic root, fourth root, or any root. In this case, we're really working with square roots. So these two expressions here, square root of 2 and square root of 8, are the radicals. So let's go ahead and try and work with them. So if you notice here, I am actually asking you to multiply the two radicals by 4, and each of the radicals has a number, a whole number in front of it. So 2 root 2 really means 2 times root 2, and it's a part of a term. It makes up a term. Similarly to 2x. 2x is like a term. It really has a multiplication between it. 2 root 2 is the exact same thing, except it doesn't have an x between with the 2. It actually has a radical with it. How would I go about multiplying 4 in? Well, I'm going to put my bracket together. I'm going to, or sorry, my arrow. I'm actually going to multiply 4 into each one of the terms here. And 2 root 2 is a term, 5 root 8 is a term. So I cannot go ahead and do this. I cannot multiply 4 with 2 and then 4 with square root of 2. And then 4 with 5, and then 4 with square root of 8. I cannot do that because 2 root 2 is its own term, so you can only multiply it once by 4. In addition, when you multiply radicals, if you're multiplying by a whole number, you cannot incorporate that whole number inside of a radical. So here when I have 4 and I'm multiplying it by 2 root 2, I can really multiply the 4 and the 2 together, and that'll become 8. And then square root of 2 stays a square root of 2. It's not square root of 8 because 4, again, is not underneath a square root, so you cannot multiply it with what's inside of a square root. The second term will similarly become 4 times 5, which is 20, and then square root of 8. Again, square root of 8 stays the same. And then you would want to kind of stop here, but don't, because you can further simplify this. And what do I mean by that? This square root of 8 can actually be written as square root of 4 times square root of 2. And that really matters because square root of 4 times square root of 2 can be broken up into square root of 4 times square root of 2 by our laws of radicals. And then, Lord behold, the square root of 4 turns out to be just number 2. So when you're simplifying radicals, you really kind of want to figure out if you can break up a radicand, number inside of the radical sign, into two values, one of which is a perfect square. And I kind of like having a list of my perfect squares, and that's really 1, 4, 9, 16, 25, 36, 49, and so on. Why are these guys perfect squares? Because if I take a square root of each one of them, I will get a nice whole number. 49 is 7, 36 is 6, and so on. So this square root of 8 can, through a series of processes, be simplified into 2 root 2. I do have a 20 in front of it, so I'm just going to rewrite the 20. And then the other term, I can't really forget about it. It was 8 root 2. I can't really do anything with root 2. That's already simplified. So what do I have now? I have 8 square root of 2 minus 20 times 2. Well, that's just 40. So 40 root 2. And then you might say, well, I'm done now. There's enough math going on here. But you should now recognize that this square root of 2 and this square root of 2, well, they're the exact same. So the radicands are the exact same. We treat these two terms as like terms. So this is similarly, or similar to saying 8x minus 40x. And if you had that, you would end up with negative 32x. Similarly here, 8 square root of 2 minus 40 square root of 2 will give me negative 32 square root of 2, and that is your final answer. Now what happens when I try to multiply a 2-term radical with another 2-term radical? And that means that I've got 2 terms in my first bracket and then 2 terms in the second one. So this is very similar to FOILing, meaning that I multiplied the first term with the first term of the second, and so on. So I like putting my arrows around just so I kind of keep my mind intact with what I'm multiplying. So I do 3 times 2, well, they're just 6, minus 3 times root 12. 3 is outside of a radical sign, so I cannot put it inside. So I'm going to leave it as just 3 root 12. Plus 2 times square root of 6 is really 2 root 6. We usually put the whole number in front of the root. Minus And here I actually multiply square root of 6 times square root of 12, and I can actually multiply the 12 times 6. I know 10 times 6 is 60, 2 times 6 is 12, so square root of 6 times 12 is square root of 72. You may want to be tempted to stop here. However, now we've got to simplify our radicand. So square root of 12 here and square root of 72 can certainly be simplified. Square root of 12 can simplify into square root of 4 and 3. And again, why am I picking 4 and 3? Because 4 is a perfect square. And of course I have 3 in front of it, and there's that 6. I'm not going to mess around with that. 2 root 6. Square root of 6 cannot really be divided by a perfect square because I only have 1, 4, and 9. Those numbers are not, or 6 is not divisible by those. Minus square root of 72. You're going to think of a ton of numbers that can be multiplied together to give you 72. You can pause this video to try and figure out what the perfect one is, but I'm going to argue that the best one is 36 times 2, because 36 is of course a perfect square, and it's a good one, it's a big one. So what do I get here? I have 6 minus 3, square root of 4 and square root of 3 can now be written separately, plus 2 root 6 minus square root 36 and square root 2. And what do I come up with here? Well, square root of 4 is really just 2, so I have 3 times 2 times square root of 3 plus 2 root 6 minus square root of 36 is 6 root 2. It's fantastic. I'm nearly done. 6 minus 3 times 2 is 2, 6 root 3 plus 2 root 6 minus 6 square root of 2. And now we just have to check to see, are any of our radicands identical? Because if they are, we can treat them as like terms and add those terms together. But in this case, they're not, so we cannot add anything together. You may be tempted to say, well, 6 minus 6 root 3 is 0, but it's not. That you cannot subtract 6 minus 6 because this 6 here is connected or multiplied to root 3, so it's not a like term with just the 6 here. So this here is our final answer. Hope you enjoyed the video.